Welcome to physics class. We have um, kinematics problem, kinematics, okay. And then in the kinematics, we deal with the motion of projectiles. A plane diving with constant speed at an angle of 53 degrees with a vertical releases a projectile of an altitude of 730 meters. The projectile hits the ground after 5 seconds of release, and we are required to calculate the speed of the plane. So first, let's interpret the problem. We have x and y axis, and then the plane, that's the projectile of the plane, and then you have that angle parallel to with the vertical axis of the y. So we have that point there of release, which is x is 0, y is equals to initial height, and then we have a range and the 0 height. So 7 meters from the bottom to the top. Well, and then we have the data that we have to analyze. We have initial speed there, which is we don't know, but what we know is that we have initial angle, which is 53 degrees. We'll still need to analyze that, and change in y is going to be 730 meters, 730. And then we have time there, which is 5 seconds, 5.00. and that's all the data we have. Now we have to interpret it. So we know that final height minus initial height is going to be initial speed times sine theta. So all of that multiplied by time minus half. So that's equation of motion, g and t squared. And from there we know that our final height is 0. Our initial height was 730. The object was going down, and we have initial speed there that we need to calculate, and we say initial speed is unknown, so we write it as a v initial, which is VO subscript O, and then the theta, that is 53. So we need to find the difference. So so that will be sine. Our theta is going to be, we have to calculate, let's say 90 minus 53 is 37. So it's going down, yeah. So it's going to be 37 degrees down. Okay, so our theta there, initial theta, our angle is 53 degrees minus 90 degrees, giving us negative 37 degrees. So negative 37.0. So it's 3 significant figures that we're using, so we use 37.0 and 37.0 degrees. And then our time there is 5.00 seconds minus half. Half is 9.8 meter per second, and then we have our time, which is 5 seconds. It's 5.00, 3 significant figures, seconds, and all that squared. So we have negative 330 meter on our left hand side, and on our right we need to sort that out. Okay, that part there, using a calculator, we have that part as sine negative 37 multiplied by 5, giving us negative 3.01, negative 3.01, and then seconds multiplied by the initial speed. So that's going to be negative. Once again, we can sort that part, which is 5 squared multiplied by 9.8 divided by 2 is 122.5. So it's going to be 122.5 meter. And now we're going to have, remember we need initial speed, so it's 3 negative 3.01 seconds multiplied by initial speed is equals to negative 30 meter, and that goes that side, so it's going to be positive. So we're going to have a positive value, which is positive 122.5. and now that gives us we need to calculate initial speed, so that's going to be negative 130 plus 122.5, no, negative 730, no, it's negative 730 plus 122.5, giving us negative 607.5 meter. Divide by negative 3.01 seconds gives us our answer multiplied by negative 3.01 seconds gives us 201. So that's going to be 202, rounding off to 3 significant places. So thank you very much. So that's our answer for A. We need to go for B. Now B, it says how far does the projectile travel horizontally during its flight. So how far they need change in x. So the change in x there is going to be range. So that's going to be our range is Vx multiplied by time. So vertical speed, our vertical speed is 0. Okay, vertical speed multiplied by cos theta. That's okay, and multiplied by cos theta Vx. So that's 2 multiplied by cos, yeah, so it's gonna be multiplied by cos theta and then multiplied by time there, which is 5 seconds. So that cancels that out, and then we have our answer as, let's check, is 202 multiplied by cos negative 37 multiplied by 5, 807, rounding off, so it's gonna be 807. That's our answer. And then horizontal component of its velocity, so horizontal component of the velocity is going to be horizontal component of velocity, it's Vx. So Vx there, sine theta, and then we're going to take 202, which is meter per second, multiplied by cos negative 37, and that gives us an answer of that gives us cos 37 negative 37 multiplied by 202 is 161. So it's 161 meter to 3 significant figures. And then we move on to vertical component of velocity just before striking the ground. And that one there we need to write the equation first. So Vy is going to be initial speed multiplied by sine theta minus g multiplied by t. So that's going to be initial speed, it's going to be 202 meter per second multiplied by sine, which is going to be sine negative 37 degrees, and from sine negative 37 degrees it's going to be negative 9.8 meter per second squared. Okay, all that multiplied by our time, which is 5 minutes, 5.00 seconds, or 5.00 seconds. And then we use a calculator and punch that all together. 202 multiplied by sine negative 37 minus 9.8 multiplied by 5 that gives us negative 171 meter per second. And that's it. That's our final answer for question D. And I want to thank you so much for watching, and please do not forget to follow or subscribe. And this is your tutor Black Adam 5D tutor. Thank you for watching, and yeah, as I said, do not forget to follow or subscribe for more related problems. Thank you.